Is Joseph.
And I'm Dylan.
We are here as partners to talk about the comparative study on the effects of some natural food preservatives on Teff-based pancakes. And our guide for this project is Dr. K. Oduse.
So, I'll introduce the topic to you. You know that food is actually an important part in our lives, right? And human survival actually depends upon the consumption of food. But do you think the food that we eat daily is actually safe? Actually, studies have shown that 70% of the food that we consume consists of chemical preservatives. That's a lot, right? And it's not safe to consume chemical preservatives. It is this problem that we're actually planning to address. So, we are planning to address this problem by finding out a natural preservative that can actually replace the chemical preservative. Thereby, we can ensure the health and wellness of the consumers.
Yeah, the problem statement in our contemporary time today, our humans are subjected to a lot of chronic diseases, cancer, breathing difficulties. And if you really look at it, some of these are accumulations of the consumption of chemical preservatives in food. And that is what this project is addressing, looking at natural solutions.
Check about the materials and methods that were employed for this research project. So, as we all know, the first step was the preparation of pancakes. So, the pancakes were made out of Teff flour, which was actually the research project name. So, we chose Teff flour just because it is gluten free. So, this was the recipe that was employed for the preparation for the batter or for the pancake samples. So, after preparing the pancakes, to the batter, we added separately the natural preservative as well as the chemical preservative.
Yeah.
So, the natural preservatives that we employed in this research project include aloe vera powder, rosemary powder, moringa powder, cloves, and apple cider vinegar powder. And in the case of chemical preservative, it was calcium propionate. So, as you can see, we mentioned 0.25% in this instant, right?
Yeah.
So, this 0.25% is actually the maximum allowable limit of preservative that a food industry can incorporate into the food samples, which is standardized by Canadian Food Inspection Agency. So, after the pancake batter was made with the preservatives, we baked the pancake, we placed it in the Ziploc, and we actually incubated at 25 degrees Celsius. This is one such picture of pancake which includes aloe vera as the natural preservative. The second step in the materials and methods included the preparation of medium. So, for this, we actually took two different mediums. One was triptic soy agar media, and second was potato dextrose agar media. So, the media were separately prepared in 800 ml of distilled water, and it was subjected to heating to make it clear, and then subsequently it was autoclaved to make it sure that it was free from any contamination. Just like how we made the TSA media, the media was also prepared in the same way. The only difference was the amount of powder that was taken for the preparation of the media. Soon after the media was prepared, it was autoclaved and it was poured into the petri plates, and it was allowed to solidify and cool down. The third or the decisive step in this actual research project was the swabbing and inoculation of the sample in both potato dextrose agar as well as the TSA, which is the triptic soy agar medium. So for that, we took a sterile swab and we swabbed on the surfaces of the pancake samples that were incubated for 7 days at 25 degrees Celsius. So after swabbing, we dipped the sterile swab with the sample into a 10 ml TS drop tester. So after mixing it thoroughly and vortexing it, we took 1 ml from the 10 ml solution and we serially diluted to the concentration of 10 to the power minus 1. And from the 10 to the power minus 1, we took 1 ml and we plated in both triptic soy agar media petri plates as well as potato dextrose agar media petri plates.
Now let's talk about the result. If you look at the table we have here in the results, if you take right on top of the table, on the top of the table, you have calcium propionate. And then down below, you have aloe vera. And if you check those two, you will see that aloe vera is compete favorably with calcium propionate on TSA. Now we see another table here showing the PDA, the growth of microorganisms on the PDA media. If you check up there also, you see calcium propionate, 2 CFU, And you go down on number 6, you see aloe vera, 2 CFU, showing that aloe vera can compete favorably with calcium propionate.
So, in short, based on the results that were obtained and analyzing those results, it was found that aloe vera actually competes on par in case of efficiency as well as reducing the microbial load in the samples with the chemical preservative that is calcium propionate. So, this actually implies that natural preservatives do have the potential to replace the chemical preservatives.
Now we'll talk about the applications to the food industry and consumers, which is part of the reason why we did this project. Now, you see that consumers will be more confident that they are eating food that is healthy. That is why we say that getting aloe vera to replace calcium propionate will be more effective and it will be more healthier for consumers. And then also companies, industries can claim that their products are from natural origin, which will give more comfort and more assurance to consumers that they're eating foods that are healthy. And companies can sell this product also with natural origin at a premium.
You can see these are the references that actually helped us guide through the entire research project.
Thank you for listening.